fun experiment. What did we learn yesterday about the transfer of heat, Alina? No.
Yesterday we learned about that we got soda.
Okay, we had soda in 1 cup.
And we had ice cream.
And we put the ice cream into the soda. What temperature was the soda? Did it come out of the refrigerator? Was it cold or was it room temperature?
It was the room temperature.
Okay, room temperature
the
soda.
ice cream was in the freezer.
Okay.
And then you put the ice cream inside the soda.
Mhm.
And then the soda got cold.
The soda got cold. Is that what happened? Did we discuss that the heat went from the ice cream to the soda? Or did we discuss that the heat went from the room temperature soda to the frozen ice cream? What do you think, Ivanka? What do you think? Okay, you're right, Alina. We put the ice cream in the soda and we did see the soda melt, but the transfer of heat didn't go from the colder object, the ice cream, to the soda. It went from the soda to the ice cream, which made the ice cream melt, okay? All right, go ahead and open up a fresh sheet in your science notebook. And go ahead and put today's date on it. I want you guys to go ahead and write your goal. I can identify basic forms of energy. And after you write your goal, I want you to go ahead and write your essential question. What is friction?
Wait, I think we wrote this before.
You did. We did work on friction before. That was the day that we were rubbing our hands together. And that's the day that Mrs. Stallings had that little device that, but I want you to start a fresh sheet because we're doing something else today. We're just continuing on the friction, okay? Thank you, Nathan.
I can understand that.
It's okay. We're just picking up where we left off a few days ago. Okay, if you're done writing that, I want you just thinking, what is friction? Because that's what we're going to discuss in just a minute. What is friction if you're done writing? Okay, we're thinking about what is friction. You finish writing that question and you can tell me what friction is. Raise your hand. Luna?
Friction is when two objects rub together and they make a spark.
Good job. That's a great way to describe it. I've also got it written as resistance. Resistance. Who knows what resistance is? Okay. You know when you have two magnets and you try to put them together and you feel them pushing away? You feel the pushing away?
Yeah.
That's resistance. For example, Ariel, put your hand up. Okay. So if I'm trying to push against Ariel's, put it out hard. If I'm trying to push against Ariel's hand, she's giving me resistance. It's not easy, okay? So friction is resistance that one surface or object has when moving over another surface or object. And yes, Luna, you said that it can cause a spark. I think what you meant was it can cause heat. Yes, friction can cause heat. That's why when we rubbed our hands together, the more we did that, the warmer they got. And we also discussed when you rub two ice cubes together, what did they do?
No.
They melted because of the heat. So go ahead and write that down, that definition.
I thought they would make oh no, what happens if you ever rub two dry ice?
Dry?
2 cubes of dry ice.
I don't know what would happen if you rub 2 cubes of dry ice together, honestly. Because that would be like a chemical, when you're talking about dry ice, remember we discussed that that's a chemical, with a chemical energy. I don't know what would happen in that But I know you can't touch it because you would be burned. Okay, finish writing this down. Okay, once you've written that, I want you to go ahead and draw this graph. You're making 4 sections. It's for an experiment we're going to do. I'll give you directions on that later. But basically, you want to just write down the surface that we're using. So in the first box, we're going to be doing an experiment on the smooth floor. And then I want you to write under it distance. Okay, so go ahead and copy that graph. Make sure your handwriting's neat. In the second box to the right, tablecloth. You have space to write distance. That's fine. You're not drawing pictures in these boxes today, in this chart today, so really we're just putting a minimum, just a little bit of information in, so you don't have to have a lot of space. That's why mine's smaller too. Okay, so as soon as you're finished writing that down, go ahead and finish that, take another minute or two, and we're going to watch a short video on friction, and then we're going to conduct a fun experiment. Might not be as much fun as ice cream, but it's fun. Good. You're almost there. Almost done with the sentence. Dry your breath.
Done.
Okay. You're gonna do it on the other section. I don't have enough room. Good job, Ariel. You're done. Okay, go ahead and finish it up. Take 1 more minute to finish it up. You guys are done? Good. we wanna have enough time for the experiment, so go ahead and finish up. You know, we got a couple people that are almost done, go ahead and finish. Raise your hand if you're still working on it. Okay. Finish. Okay, so what I'm gonna do now is if you're not done, I'll bring my notebook around so you can copy my notebook, because if you're not done, you're almost done. And we're gonna watch a short video on friction. Mark, will you get the lights?
It's gonna be a song again.
It is a video. Okay. Select a surface for the ramp, then click the go button to push the wooden box along the ramp. Can you pass this to Chris, please, Ariel? Pass that to him. We'll pass that around just a minute. Okay. Chris, will you please take it to Nathan? If Nathan needs it. Quickly and quietly. Okay, so we have different surfaces that we can select here. We're talking about friction. So here we have, we're going to make a decision, okay? We know that friction, and we discussed what friction is when two objects or an object and a surface rub against each other, okay? So that means that do all objects have the same amount of friction? Would the carpet have the same amount of friction if I were to roll a marble across the carpet as the smooth floor, or would the marble go farther on one of the surfaces? What do you think? What do you think, Mark? Do you think that the marble would roll the same distance over the carpet as it would the hard floor, or do you think that it would go farther and roll easier on one surface? What do you think? Do you think that the carpet and the smooth floor, hard floor, do you think that they're both the same? Are they the same, or are they a little bit different? They're a little bit different, so maybe they might have a different amount of friction. Let's see what happens. Let's look here. We're going to choose between metal, wood, and sandpaper. We're going to start with metal, okay? And we're looking right here. This is the surface, okay? This is the metal, and we're going to see how far this block is able to travel, okay? Was that pretty easy?
Yeah.
Could you compare that, even though the floor is not metal, could you compare that to the floor and say that's a pretty smooth surface? Okay, let's try a different surface and see if the amount of friction changes, okay?
You have to press reset.
I know. Oh, there we are. Thank you, Chris. Okay, so now we're going to select wood, okay? You see how the floor changed? It's wood. You guys have felt smooth metal before?
Yeah.
Okay, you've also felt like a wood block before. Okay, maybe it's not as smooth. Let's see how far it travels. Did it go as far?
No.
Okay, raise your hand if you think it did not go as far. Okay, good. Put your hands down. Luna, why do you think it did not travel as far?
Because the floor is a little bit more rough.
Okay,
Cause more friction.
very good, Luna. Luna said that because the wood was a little rougher, it had more friction. Thumbs up if you agree with Luna. I agree with Luna too. Okay? All right, let's try one more. Sandpaper. What do you think is going to happen when it's on sandpaper? Joanne, what do you think? Do you think the sandpaper is going to have more friction than the wood? You think it is? Raise your hand if you agree with Joanne. You think the sandpaper is going to have more friction than the wood? Raise your hand if you've ever felt sandpaper. Sandpaper, good, you can put your hands down, so you know is very, very rough. Let's see what happens. We're gonna choose sandpaper. Did it go very far? You're right, Joandy. The sandpaper had more friction than the wood, and the wood had more friction than the metal floor. Okay, Joandy, will you turn the light on? Okay, we're gonna do an experiment. We're probably only gonna have time to do 2 different surfaces, but this is what we're gonna do. Don't get out of your seat yet. You have your groups, and you're gonna take your notebook with you. Use yours as an example. Right now we can do 3 different surfaces: the smooth floor, the tablecloth, and we're gonna do the carpet, okay? So, each group is gonna get a marble, 1 marble. Each group is going to get a tape measure, and we have enough that we can take turns. We can do 2 groups on the carpet. We can do a group on the floor. We have enough space that even if another group finishes the carpet, you can go to the smooth floor, and we have the tablecloth. This is what you're gonna do. You're gonna take your marble, 1 person in your group's gonna take your marble, and you're gonna see how far that you can roll your marble across the surface, and you're going to measure the distance. Right, Randy? You're gonna measure the distance, so 1 person needs to be in charge of measuring, and you're gonna see how far it goes, okay? All right, so go ahead and get in your groups. This group, I want you guys to go to the carpet.
Are you going to get the marble?
This group's going to be on the carpet. Hold on, don't go anywhere yet. You guys are fine. You guys can go ahead and go to the carpet. Mark's group, you can also go to a different section of the carpet. Mark, come get this. Yeah, you can leave it. Okay, Mark's group's going to be on a different section of the carpet. Alina's group, you're going to be with the tablecloth. Okay? Come here, Alina. Make sure you get make sure each group needs a science book and also a ramp, okay? That way you can keep it consistent. Mark, your group needs to go ahead and get a science book and a ramp, because you want to make a ramp for it too, okay? That way you're not, it's going to be consistent.
A ramp?
Your group will be on the hard, okay?
Got it.
Anywhere over here on the hard floor. Okay, so this is what I think you should do. I think you should make a ramp. But you want to use, you're only going to use 1 book, that's fine. If you want to use 2, use 2 both experiments. Because if you push it, then you might push it harder one time than the other. So I think you should make a ramp and try to make it the same every time. Raise your hand if you need some books. You guys have a book?
No. Really? Because I put nothing.
Use 2.
Oh, no. You just said, oh, I can't. You're welcome. What are you guys deciding? Joanny, watch your fingers. Luna, does your group have a ramp? No.
Okay. Make sure you measure your distance and record the distance from the same place every time. And you put them one on top of the other. Okay.
She said flat. Has to be flat.
Right.
Oh, like this. How's that gonna work?
I agree with her. Put both books like this. Like here. You're right. Okay. And yeah, move everything out of the way. When you're measuring, make sure you measure from the same point every time. If you're going to measure, I would measure from the end of the ramp to where the marble stops. And I would do the experiment more than once. Okay. Remember when we had the cars? Remember how we had both the books on one on top of the other? That's what we're doing this time. And how would we make the ramp? I think you could do it like this. There you go. measure. And make sure when you measure from the end of, you measure from the end of the ramp to where the marble stops. Make sure you do it twice on the same surface just to check the result.
We need to go.
Okay, good. You guys have everything set up. I'm going to roll it down here because we're going to need it. A little gently. Okay. All right, come on, you guys. You have 5 minutes. You guys want to make sure you get more than one surface. You are. Yes, you are. Okay, who's in charge of rolling it? Who's in charge of the marble? Actually, you're going to stay down there because we have 4 other people. Why don't you do that one, okay? You can be in charge of dropping the marble down the ramp, okay? And maybe, Alina, maybe you can measure. So Nathan, we can't measure yet because we haven't done the experiment. So why don't you let Luna go ahead and roll the marble. There you go. Okay, alright, so look, there's one thing that I see. Take the books off and take the board off. Quickly take the marble off. And move the board. Flip it. There's one thing that I saw, that's going to affect your experiment. Because the ridges were up. Okay? Yeah, it is. Okay, go ahead and put your books down. Okay, that's better. Okay, now go ahead and try it. How many times do we have to do it? Twice on the same surface. So then you move to a different surface. So once you've done it twice, if you're on the carpet, you move to the hard floor. If you're on the hard floor, you do it on the carpet. What?
How can I measure all the way over there?
Oh, let's think about it. If something,
60.
well, you would measure. What did we do last time? We had to measure. We had to use the same idea last time with the cars. What did we do last time? We put the cars down the ramp.
So much measuring tape.
Okay, this is what you have to do. Listen, if you run out of measuring tape, then hold this down. Bring it down all the way. Exactly. You're going to put your finger and mark where the 60 is. Right here. And then you bring this let go. And you bring this down. No, you get the idea? Right here. Okay, now pull it down tight. Watch your hand. Hold on. It's got to be flat. It's not flat. See, it's just flat. And you have to add those numbers together until you get to where the marble is. You add the numbers together. If it's not flat, it's not going to be measuring in inches. There you go. Where's your marble go to? Okay, so now you have 60 and 60. What's that? Now, you do the same thing where you're at 60, starting with 1, and add on those numbers. Okay, we have about 2 or 3 minutes left. What did you guys get done? What did you guys measure on the carpet? Okay, so the 99 and the 100 are closest together, so we're going to say that that was consistent. So you can say it's 100. Okay, so did you guys write your distance down? And you're going to say 100 what? Was it in inches you were measuring? You measured on this side? Did you have to do it more than once? Then you weren't measuring on this side. This side only goes to you. Okay, if you have a marble, and we're not rolling the marbles just for fun. We're using them as part of the experiment. So, okay, so if I walk around, by now everyone should have some distance written down on their paper. Okay? If you've already done the experiment twice on the hard floor, or twice on the carpet, then you're done and you can go have a seat. We only need 2 times on each surface. Okay, so you measure on this side. You guys have you've already measured it twice. You don't need to measure it anymore. Did you do the hard work? So you don't need to do it anymore. Okay? You guys actually ran out of time because you used your time on this course. You guys can go have a seat, okay? measure. I went to tape measure. Okay, I want you guys to freeze and look up here. Shh, freeze. Chris, eyes up here. I want you guys to go ahead and stop where you're at. And it's time to clean things up. We'll finish this. We'll probably finish the other half of this tomorrow, okay? So stop where you're at. Return the books. Return the ramps. Get your things and go line up. They're all rolled up. Rolled up.